Yes.
Hey,
That's the plan.
Okay, so once again, if you understand, this is just 1/2 times 32 times 450 squared again equals 1/2, but we're not using oxygen, or not using nitrogen, we're using argon. So what mass did you put in for argon? 40 gram per mole times d squared. And once again, the argon. So once again, the mass is larger, so we expect the velocity to be smaller. What did you get for argon?
402.49 meters per second.
402 meters per second? Okay. Does this idea make sense, what we just did? Okay, now my question for you is this. Imagine you had an unknown gas traveling 3 times slower than oxygen. What would be its molar mass? How would you go about solving this? Yeah, you just come up with a speed. Maybe oxygen is moving 3 and the unknown gas is moving 1. Maybe oxygen's moving 30 and the unknown gas is moving 10. Maybe oxygen's moving 300 billion and the unknown gas is moving 100 billion. Okay? If you get a situation like this, you just come up with a velocity. So go ahead and come up with a velocity, hopefully different than your neighbors, and then figure out what the unknown gas's molar mass is. Any other victims? I like the old ones because the old ones don't have that secondary trigger. And they can actually be refilled. They actually have a little refill valve in the back of them. But they don't sell those ones anymore.
Yeah, because it has to be child-proof. That one's sad. How does someone break it?
I don't know. It's sparking, but there's no gas coming out.
So your trigger's messed up?
I'm sorry?
So the trigger's messed up? Or the little top plug's messed up?
Yeah, the trigger that turns the gas on.
Are you triggered?
At least the torch, that torch still works. Let's see what this one.
You light it with a different one. I can hear pulling out gas. I'm putting out a lot of gas.
I'm just putting out too much gas. Yeah. Well, my idea of getting rid of matches might not have been a good idea. I would just stop using matches. Oh well.
Okay, so again, in going through this, you just set 1/2 mv squared equals 1/2 mv squared, gas A, gas A, gas B, gas B. So oxygen is still 32. 30? All right, make it 30 speed units. And then 1/2, and now we're looking for MB. And if oxygen is 30 speed units, then the unknown gas would have been 10 speed units. So how fast, or what's the molar mass of this heavy gas? 288.
88 grams per mole.
288 grams per.
Yes.
Okay, how are we doing? We're almost done. One more thing to do. I got some water in here, and I have a question for you. If I spill this water on the desk, like this, what's going to happen to this water? It's going to sit here forever, right?
No,
It's going to be like, when we come back in September, it's going to still be here? No, what's going to happen to it?
evaporate.
It's going to evaporate. Why does it evaporate? As it gets warm. You know the boiling point of water is what? 100.
You have to count.
100 degrees Celsius. The boiling point of water is 100 degrees Celsius. And clearly this is not boiling, okay? Because I'm not like, my hand! So it's not boiling, but you know that it's going to evaporate. Who remembers why? Yeah. Because all liquids, it has something to do with atmospheric pressure.
Alright.
All liquids exert a vapor pressure. There are, and the reason coils is if you were to graph the temperature of gas versus the percentage, then you get what's called a distribution that looks like that. Okay. So this is a temperature distribution where there are some gas molecules that are over 100 degrees Celsius, and there are some gas molecules that are at 0 degrees Celsius. So those gas molecules that want to, this is just warm, it's not boiling hot. Those gas molecules that are over 100 degrees, they want to get into the gas phase. All liquids want to get into the gas phase. But there's something keeping them from doing it readily. What's that something that's keeping it from doing it? Yeah, atmospheric pressure. So if I get a syringe, and I fill up a syringe with liquid, there's some warm liquid. Again, it's not boiling, it's just warm. And the liquid in here has a little bubble up there, and that bubble of atmospheric pressure is keeping the liquid from boiling. But what happens when the atmosphere...
Oh,
these are new syringes. Let's try that again. What happens when the atmospheric pressure goes away? It boils. So, and again, this is not boiling water. It's warm, but that's about it. So there's temperature in there that once there's molecules that want to get in the gas phase, if you take away the atmospheric pressure, keep them from doing that, then they boil. Now, I'm going to send this around, but as you just saw, these syringes are not the strongest syringes in the world. So
don't go.
Don't blow yourself up.
Just
Anyone know where my other one went? Oh, here we go. Here's the other one. This one is a much higher quality syringe.
I want that one.
No, you got that one instead.
Don't mess up. No pressure.
So the concept we're looking at is this idea of vapor pressure. And all liquids have a vapor pressure. All liquids have in their distribution some molecules that want to get into the gas phase. What's keeping them from getting into the gas phase is the atmospheric pressure pushing back down on them. You take away that atmospheric pressure, and what is the word we use when vapor pressure is larger than atmospheric pressure? Starts with a B. Boiling. Yeah, boiling occurs when the vapor pressure is larger than the atmospheric pressure. Now you can accomplish this two ways. You can shift this distribution over by heating the water up. When we want to make the mac and cheese or the ramen, we heat it up till it boils. Once there's enough molecules that there's so much pressure in the liquid, they can overcome the atmospheric pressure, it boils. Or we can just take the atmospheric pressure away, like we did in the syringes. This is why there's usually two sets of instructions on your mac and cheese box. One for Las Vegas and one for Colorado Springs. Okay, questions? Cool, and we are done.
I'm surprised no one's just gonna let it shoot out.
What were you
Yes.
planning on doing with that test tube?